we are going to cover the age-old question, what is an IP address? First off, whenever you're using a computer, you have an opportunity to connect to the internet, and we do so with a protocol called IP version 4. So if I were to open up a command prompt on my computer and I were to type in ipconfig, I will see a listing of my IP address. As you can see here, I have an IPv4 address. So and the address is listed right here. So I'm going to go ahead and draw that up here. So I have this thing called an IP address, and that IP address is hold on a minute. That IP address is 192.168.1.3. This is what is called an IP address. And basically, we need an IP address in order to communicate on the internet. And this is referred to as an IP version 4 address, IPv4. We make a big deal about IPv4 because IPv4 is the way we've been doing IP for many years. And recently, there's been development of a new protocol called IPv6. And so IPv6 is the enhancement to IP version 4. Anyway, so moving on, we are talking about IP version 4 addressing. And so as you see here, we have an address called 192.168.1.3 is the IP address. So let's talk about what this IP address is. First off, this is written in what we call dotted decimal notation. Dotted decimal. Meaning there are some dots here, and each one of these areas, each one of these things right here are written in decimal. So this number 192 is a decimal number, 168 is a decimal number, 1 is a decimal, and 3 is a decimal. These are decimal addresses, and they are separated by a dot, so therefore we call it dotted decimal. Every one of these areas is referred to as an octet. Octet. There's a reason why this is referred to as an octet, and I'm going to talk about that now. There are 4 octets. Each one of these octets is represented by 8 bits. And so now I'm going to explain. In order to understand what the difference is between the decimal addresses and binary addresses is key to understanding why we call these octets and why we refer to this as a dotted decimal notation. So we have to understand the difference between decimal addressing and binary addressing. So decimal and binary addressing, you have to understand the difference between decimal and binary. First off, the decimal system is what we call base 10. And there's a reason why we call it base 10, and we have to go back all the way to elementary school days when we were in like 3rd grade. And we learned some very important points back then. We started to understand a little bit about the decimal numbering system. And it's really easy for us to understand. And the reason is because we have 10 fingers. And so we're able to count in tens pretty easily. I mean, my kids were able to figure it out at a very young age to go from 10, 20, 30. They could count in tens because they have 10 fingers. Now imagine if we were born without 10 fingers, but rather born with, 1 finger. Then we would be base 2. And this base 2 is called binary. And let's get down to the basics. Every placeholder in a base 10 system, so every placeholder in a base 10 system can have 0 through 9 digits in that placeholder. So if I were to have 2 placeholders, both of these could have 0 through 9 digits in that placeholder. And so what we learned is that these placeholders, this would be what we call the ones, This is the placeholder for the ones. And this is the placeholder for the tens. And this is the placeholder for the 100s. Because we're going up in increments of base 10, powers of 10. So if I were to write a number here, 1, 1, 1, right? Then I have learned that I have 1 ones, I have 1 tens, and I have 1 100s. Right? And I've memorized I've memorized this, and I've learned to call it 111, and that's just simply language. I've learned to call it 111. But really what it is 1 100, 1 10, and 1 ones. Of course, in the decimal number system, we don't have to have these as just ones. We can put some other number in there. We can make this 3, 2, 0, right? And so in this case, we would have 0 ones, 2 tens, and 3 100s. And so we've learned to call this 320. But that gives you an idea of how this works. So every placeholder, as we go up, goes up in increments of the power of 10. So this would be the thousands. This would be the, and just keep going up. So you got your thousands, your tens of thousands, your 100,000. You keep going up, and we go up in increments of 10. That's how the decimal number system works. Now, let's pretend that these placeholders here no longer were base 10. But rather, these numbers were base 2. So if these numbers are base 2, then I could only have 2 placeholders in here, a 0 or a 1, right? So each placeholder can only have one of 2 possible digits. I can either have a 0 or a 1 here. Consequently, because this is base 2, this is the ones column, just like it is in decimal, but this right here is the 2s. And this is the 4s. And this is the 8s. And the next one is the 16s. And the next one is the 32s. Why? Because these are going up in increments of the powers of 2, or base 2. Why do they go up in the increments of power 2? Because I only can put a 0 or a 1 here. I only have 2 possible combinations. So go back to my previous example, the one that I did with the decimal numbering system. If I did 1, 1, 1 here, right, then I have learned that I have 1 ones, right? In fact, let me erase this. I have 1 ones, 1 2s, and 1 4s, right? So I have 1 1s, 1 2s, and 1 4s. So this is no longer 111. In the base 2 system, this is 4 plus 2 plus 1. In the base 2 system, this is actually representative of the number 6. So in the decimal number, we may call this the number 6. So in decimal, we just write 6. But in binary, we write 111. Nope, that was bad. See, I used decimal terminology. We write 111, right? So in decimal, we would call this 111, but in binary, it's 111, indicating 1 4, 1 2, and 1 1s. So there you go. So I got an idea for you here. If we were to take any number, then, so if I were to take any number right here, so we're gonna just pick a number. I'm gonna pick a number. We're gonna pick the number decimal number. Let's pick the decimal number 19. Seems like a fair number. So I'm gonna pick the decimal number 19. How do I convert 19 into binary? Well, that's a good question. It's pretty easy, actually. First, I'm going to take the number 19. I'm going to ask myself, what is the highest power of 2 that can go into 19? Well, the highest power of 2 that can go into 19 is 16. So I'm going to go ahead and mark this as a 1. I have 0 32s, right? But I have 1 16. So I'm going to take 16 out of that 19, And that leaves me with 3 left over. So I'm going to ask myself, does 8 go into that 3? No. Does 4 go into that 3? No. Does 2 go into that 3? Well, yes, it does. So I'm going to mark that as a 1. So now I'm going to take the 2, and I'm going to come down to a 1. Now, does the 1s go into the 1? Well, yes, it does. Right? So this is called binary. So the number 19 in binary, then, is 0, or actually, I don't even need to put this. I don't need to put the leading 0. Don't even worry about the leading 0. I'll put 1, 0, 0, 1, 1. That is the binary equivalent of the number 19. Make sense? Pretty easy stuff, actually. Let's get a little bit more complicated at it, though. Let's deal with a larger number. Let's talk about an octet. Okay? So an octet in IP addressing, an octet is one of those dots. So we'll say the number 192. Remember, 192 dot, and then we would go to 168 dot 1.3, right? So the octet, this is an octet, and this is written in decimal notation. So if I wanted to convert that to binary, right, every octet is going to require 8 placeholders. 1, 2, 3, 4, 5, 6, 7, 8. So every octet is going to represent 8 placeholders. That's why we call it octet, because oct is 8, right? So 192 is going to convert into 8 binary numbers. So we have to ask ourselves, how's that going to happen? Well, that's easy. I'm just going to take 192 over here, and now I'm going to calculate. I'm going to first figure out what these placeholders are. So I just want you to remember, this is the 1s column. This is the 2s column. This is the 4s column. This is the 8s column. This is the 16s column. 32 column. 64 column. And 128 column. By the way, it's a good idea to remember and memorize the powers of 2, right? What are the powers of 2? Let's just real quickly do that. 2 to the power of 0 is 1. That's this one. This is 2 to the power of 0 right here. 2 to the power of 1, which is the next power of 2, is 2. 2 to the power of 2, which is the next power of 2, is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. 2 to the power of 5 is 32. 2 to the power of 6 is 64. 2 to the power of 7 is 128. Now, if we wanted to keep going, we'd say 2 to the power of 8 is 256. 2 to the power of 9 is 512. 2 to the power of 10 is 1024. 2 to the power of 11 is 2048. 2 to the power of 12 is 4. Yep, you were right. 4096. I knew you knew that, right? So anyway, I would recommend memorizing the powers of 2 up to 12 at least. But we stop here, right? Because in IP address land, an octet only uses 8 digits. And in this case, since we started at 0, it's going to go 2 to the power of 0 all the way to 2 to the power of 7. So we're going to get this. So 192 can be converted then to some binary equivalent. So how do we do that? Well, what is the highest power of 2 that goes into 192? Well, 128. So we're going to mark that as a 1. And so we're going to take 128 and subtract that from 192. Right? So, all right, well, we have to do a little math here. We're going to take 12 from here, and then we're going to take them, and, we're going to do our basic elementary math, right? So what is this? This is a 4. 8 minus 2 is 6, 64. So now we're going to ask ourselves the next question. What does 64 go into 64? Well, yeah, it does. So I'm going to now subtract 64 from there, and that is 0. So now all of these remaining digits are 0. So the dotted decimal is 192, but the binary is 11000000, right? So if we wanted to continue going on here, and we do, right? We do want to continue on. Hold on, let me give myself a big eraser. All right, so we do want to go on. So I'm going to convert 168. So once again, we have 1, 2, 3, 4, 5, 6, 7, 8. Eight areas for the for that octet. So we're gonna have to ask ourselves, okay, does 168, all right? What is the highest power of 2 that goes into 168? Well, 128. So we're gonna mark that as a 1. And then we're gonna subtract that from 168. So that's gonna be 40, right? So does 64 go into 40? No, so we're gonna mark that as a 0. Does 32 go into 40? Yes, it does. We'll mark that as a 1. And now what do we have left over? 8. Does 16 go into 8? No. Does 8 go into 8? Yes, it does. So we're going to mark that as a 1, and we're going to subtract 8 from there to leave a remainder of 0. And now we've got 0, 0, 0. So that is the second octet in our scheme. So we figured out 192, 168. Now we got to go to our third octet. Right? And this is now converted into a, also gets converted into a binary address. Now this one's easy. Does 128, what is, so 128 doesn't go into 1. 64 doesn't go into 1. 32 doesn't go into 1. 16 doesn't go into a 1. 8 doesn't go into a 1. 4 doesn't go into a 1. 2 doesn't go into 1, but a 1 does, right? So that's pretty easy. And now you should be able to figure out this last one pretty easily. Right? No 128, no 64, no 32, no 16, no 8, no 4, but we do need a 2, and we do need a 1. So there you go. So you can go home and tell mommy today that 11 equals 3. Get it? Do you get that? 11 equals 3, right? So actually, 1 equals 3. Do you understand? Do you see how that works? That's how it works. So awesome, right? So yeah, we always joke around in networking land that you always learn that 1 plus 1 equals 2. But we believe in binary world that 1 plus 1 equals 3, right? There you go. So now you know why 1 plus 1 equals 3. And you're now part of the joke. You might have seen a t-shirt that says there is 11 type of people that understand binary, those that do and those that don't, or something like that. I forget exactly how it goes, but that's pretty funny thing. All right, so anyway, that is how you convert an IP address into binary. But why the heck do I need to know that? Right? I mean, who cares? I mean, why do I need to know that this IP address converts to binary? Well, let me show you why. So on a network, you have this thing called an IP packet. And the IP packet gets transmitted across the network. And we have our data in there. So maybe we want to send we want to send an email or something. And so we've got our data in here. So our data is put inside this packet. the packet has a header. One of the primary responsibilities of that header is to provide a destination address. It's kind of like this. If you were to send a letter, you would require an address in that letter, would you not? So that letter could then be appropriately delivered over our mail system. So the idea is that along the way, this letter, somebody is looking at this address right here, right? Somebody is looking at that address along the way. So it goes inside your mailbox, right? Okay, here's my really crude representation of a mailbox. It goes inside your mailbox, and then it travels to the mail truck. All right, here's a real great mail truck. Oh boy, oh boy. Hey, that didn't turn out too bad. It goes in the mail truck. It goes to the post office. Is that a post office? I guess so. And eventually will wind up at the other mailbox that you're trying to get to, right? But each step along the way, somebody is looking at this address to try to figure out where it needs to go. This is called end-to-end delivery, right? So that's pretty neat. So this destination address, or what is referred to as the logical address, is the IP address. This is what we see up here, the IP address. It is converted to binary because as the packet gets delivered from device to device, so it goes from computer to router right? To another router, to another router, to another router, to other machine. Every device along the way needs to detect or look at this address and make decisions about it. They do not have time to be messing around trying to figure out human readable stuff like decimal addresses. Rather, these devices look at the binary address and they evaluate this address as it comes through and they make decisions on it. The decisions, and by the way, all these routers put together, we now affectionately call the internet. Or not anymore, we now call it the cloud. Right? Because we're cool. We call it the cloud now. Or whatever we call it, right? But nonetheless, basically these devices look at that destination address and they are able to send it through these routing devices to eventually receive at the other end device. So let's take a look a little bit more carefully. This IP address gets evaluated by each router, and each one of these routers makes an important decision called a routing decision. And that routing decision is based on something very important. Every IP address is able to divide up into two important considerations, right? So an IP takes care of two issues. Number one, it determines the node address. And I just used a bad word there. We'll say host address. Sometimes you'll hear it referred to as node by us old school networking guys. The second thing it does is it's able to determine what network it is on. So 192.168.1.0 can be determined to be one. I'm sorry. I didn't mean to say 1.0. I meant to say 1.3. This can be broken up. Dot 3 represents the host, and 192.168.1 is the network. Now, the question is, how does the router know to break this up between host and network? Well, the how is very important. There are two ways that it could have happened. The first way is the old school way, and that is called classful addressing. The way we do it now is the new way, and we call it CIDR, classless inter-domain routing. And so these are two concepts that you absolutely have to understand, and we will be introducing those at a later date. But basically what I've shown you today is how to convert your dotted decimal address into binary. Understand that routers make routing decisions based on the binary equivalent of your IP address, and they determine by looking at the IP address what the host and what the network is. Now, today, we use CIDR to figure that out. We used to use classful addressing, and I will introduce both in a discussion at some future day.